Good evening, students. Good evening, students.
Good evening, sir.
How are you?
Good afternoon, sir.
Fine.
Good afternoon, beta. So today I am going to start new topic, Bell-Coleman cycle. Okay. So under Bell-Coleman cycle, so this type of cycle was used in Ishitai during in the ship for carrying the meat from one place to another place. Okay. So look at here. So how this Bell-Coleman cycle is working? First of all, look at on this diagram. First one, the air is coming inside the compressor. So look at here. This is your compressor in which gas is compressed. After compression of gas, its pressure and temperature will get increased. Okay. After compression, it will go to the cooling space. Cooling space. Okay. So when it will pass through the cooling space, so what will happen? It will be cooled with the help of cooling water. Okay. So this will be cooled with the help of cooling water. Okay. After this, it will pass through the expander, where it will expand. The gas will expand, whose again pressure and temperature will get reduced. Here. Pressure and temperature will get reduced. After it will pass through the refrigerating space. When it will pass through the refrigerating space, there it will take the load of heat and its temperature is going to increase at constant pressure. So this is for open cycle. Here air is fed to the open space. It is not passing through the pipe, as I have already explained in previous lecture, that this is fed directly to the space which is going to be cooled. Okay. So, but in case of closed cycle, this is case of open cycle. But in case of closed cycle, the air is moving. The air is moving through the pipe, not directly fed into the room. Okay. It is moving through the coil. As I will take the example of refrigerator, in which your refrigerant is flowing through the pipe, and it will take the latent heat from there. So what it means? It is passing through the pipe. So in this case, when the air is passing through the pipe and it will take the heat load from there, that is called the closed bell type system. Okay. So this is open bell type air Bell-Coleman cycle, and if air is passing through the pipe, then that is called your closed Bell-Coleman type cycle. So look at the PV and TS diagram. So this is your PV diagram. 1 to 2 is your isentropic compression. 1 to 2 is your isentropic compression. 3 to 4 is your isentropic. And look at here. Here, so the pressure P3 and P2 is same, and here P4 and P1 will be same. Here, temperature is reducing when it will passing through the coolant, okay, cooling space. Then the temperature is reducing at constant pressure P2 to P3, and here the refrigeration effect will occur at constant pressure P4 will be equal to P1. Okay. So this is the Bell-Coleman cycle whose TS diagram. Everybody must draw this diagram side by side. So this is your TS diagram. Look at here 1 to 2, 2 to 3, and 3 to 4. 4 to 1. And the temperature T2, this is the temperature T3, this is the temperature T1 and T4. So this is the temperature and entropy diagram. So look at here. First of all, when air is compressed inside the compressor, whose pressure and temperature both are going to increase. So this process is known as isentropic compression. As I have already told you, what is isentropic compression? Under isentropic compression, there is no any heat loss or heat rejection to the system or receiving from the surrounding. So there is no exchange of heat between system and surrounding. That is called your isentropic compression. Okay. After this, look at here. During isentropic compression, both pressure and your temperature will get increased from 1 to 2. After this, it will passing through the cooling space where it is cooled with the help of cooling water. Okay, where it will reject the heat at constant pressure. Look at here, where its temperature is reducing from 2 to 3 at constant pressure. And so here the pressure will be P3 will be equal to P2. At constant pressure, its temperature is going to reduce. After this, it will pass through the expander. When the piston is moving from top dead center to the bottom dead center, when the gas is expanding inside, when the air is expanding inside the cylinder, its pressure and temperature both will get reduced. So look at here, the temperature from 3 to 4. The temperature from 3 to 4 is going to reduce, and the pressure is also going to reduce from 3 to 4. Okay, and last 4 to 1. 4 to 1 is your where refrigeration effect will be occurred. Okay, so when the air is passing through the where refrigeration effect will be occurred, from where it will taking the heat. Okay, then where this means the refrigeration effect will occur at constant pressure. Look at here. So when it will passing through the refrigerating space, when then it will take the heat from there, its temperature is going to increase from T4 to T1. Okay, so look at here about the specific volume from 1 to 2. So look at here, this is your cylinder piston arrangement. When your compressor is working from top, bottom dead center to top dead center, what will happen? It has maximum specific volume. Okay, so it is going to compress. When it will going to compress the charge, its specific volume is going to decrease. So during 1 to 2%, this specific volume is going to decrease, and its pressure and temperature both are going to increase. And 2 to 3 at constant pressure. Look at here, 2 to 3 at constant pressure. Then 3 to 4 during expansion. What will happen? During expansion again, your specific volume is going to increase, and pressure and temperature both are going to reduce. Okay, so this is all about this Bell-Coleman cycle. First of all, everybody must draw this figure. Then I am going to explain the derivation. Now, beta, first of all, the isentropic compression was for this. Okay, during isotropic compression, there is no any heat loss or gaining from the system to the surrounding or surrounding to the system. So there is no exchange of any heat to the system or surrounding to the system. But during cooling process, there is a exchange of heat from the system to the surrounding. That will be occur at first of all, I have to draw this figure, PV diagram. 1 to 2, 2 to 3, 2 to 3, and 4 to 1. PV diagram. 1. Okay, this is your isentropic compression, and this is your isentropic expansion process. So look at here, during isentropic compression, there will be no exchange of any heat to the system to the surrounding or surrounding to the system. But during cooling, it will rejecting the heat to the surrounding with the help of cooling water. Okay, so look at here, from how much heat is rejecting to the surrounding from Q2 to 3 at constant pressure. So Cp, difference between two temperature T2 minus T3. So this will be the question number 1. Okay. And during 3 to 4, again this is isentropic expansion. There will be no any exchange of heat between system and surrounding. So there is no any heat loss. But during 4 to 1 at constant pressure, when your air is passing through the refrigerating space, it will get gaining the temperature from there. So this means how much heat is extracted from the system from 4 to 1. How much heat is extracted at constant pressure. So look at here, at constant pressure, Cp T1 minus T4. So this will be your equation number 2. So everybody note on this. So, and we know the work done, total work done, that will be equal to heat rejected minus heat absorbed. How much heat rejected and heat absorbed. So heat rejected will be Q2 to 3 Cp T2 minus T3 minus heat absorbed. How much heat absorbed? Cp T1 minus T4. So this is your work done. So everybody know what is the COP of the system? COP of the system is heat absorbed divided by the work done by the work done. How much work done? This much work done. Heat absorbed. How much heat absorbed? So heat absorbed during refrigeration effect. So T1 and minus T4 is your refrigeration effect at constant pressure. So heat absorbed will be equal to Cp T1 minus T4 divided by total work done. How much total work done? Cp T2 minus T3 minus Cp T1 minus T4. Okay. So look at here, everybody. So what will happen if I will take out the value of can you see this step here? No. So everybody must write down these questions on your notebook. Hurry up. I am going to raise it. Hurry up. Okay. Now look at here. If I will take out the value P4 from this equation number 3, then Cp T4 I have taken out. Then this value is T1 by T4 minus 1 divided by Cp is cancel out. So no need to write here the Cp value. Then here I will take out the value of T3 outside from this bracket. So here T2 by T3 minus 1 minus. Again, I am going to take out the value of this T4. Then here the value inside the bracket will be T1 by T4 minus 1. Okay. Now look at here. We know that for isentropic compression 1 to 2, for isentropic compression 1 to 2, T1 by T2, this value will be equal to P1 by P2 into gamma minus 1 divided by gamma. Okay. And what about the value for isentropic expansion? For isentropic expansion, the value T3 by T4, that will be equal to P3 by P4 into gamma minus 1 divided by gamma. Okay. So look at here. Look at here P1. Look at here P2 will be equal to P3 and here P1 will be equal to P4. So P1 will be equal to P4 and P3 will be equal to P2. So these two value, if I will divide, these two value will be equal to T1 by T2 will be equal to T3 by T4. Okay. Now when these two value will be equal, when so I can rewrite this value also like this. T2 divided by T3 that will be equal to T1 by T4. Okay. So this means T2 by T3 will be equal to T1 by T4. So look at here T1 by T4 and T2 by T3. So all these value will be cancelled out. So all this value will be cancelled out. Only the equation left only will be here T4 divided by T3 minus T4. So this is all about the COP. Look at here. So this is the COP in which all this value cancelled out. Why? Because T2 by T3 will be equal to T1 by T4. So this is the equation number 5. So everybody note on this. Hurry up. Hurry up. Note on this. Now if I will divide upper side and lower side by T4, so this value will be 1 divided by T3 by T4 minus 1. So this T3 by T4 that will be equal to P3 by this will be equal to P1 by P2 by P1. Okay, directly I can write this gamma minus 1 divided by gamma minus 1. So this P2 by P1 I can also read it like this RP. So this is the pressure ratio or compression ratio. This is known as the compression ratio or expansion ratio. RP is known as the compression ratio or expansion ratio. Okay, so this is the COP of your Bell-Coleman cycle. What is the COP of your theoretical COP of the Bell-Coleman cycle is T4 divided by T3 minus T4. Okay. So everybody note on this. Hurry up. Everybody note on this. Hurry up. I am going to raise it. Can I raise it? Hurry up. Okay. Now next. So this is the COP or theoretical COP of your Bell-Coleman cycle. So sometimes compression and expansion following the law Cvn is equal to constant. So in that case, during your compression process, the work done by the compressor during process 1 to 2, during your isentropic compression. So at mass will be 1 kilogram. So what will be the value work done by the compressor? That will be equal to N divided by N minus 1 into P2 V2. What will be the value over here? P2 V2 minus P1 V1. So this is your V. If I will, this is your value of V1. This is the value of V2. This is the value of V4, and this is the value of V3. Okay. So during isentropic, when this will following the law PVN is equal to constant, work done by the compressor, that will be equal to N divided by N minus 1 P2 V2 minus P1 V1, and everybody know PV is equal to MRT. Okay, where R is gas constant, but the value of M is equal to 1 kilogram. So PV will be equal to RT. Okay, so I can write over here work done by the compressor, that will be equal to N divided by N minus 1 RT2 minus RT1. So this is all about the work done by your compressor. Okay, now what will be the work done during expansion? So during expansion, the work done by expander, that will be equal to N minus 1 from 3 to 4. So expansion process will be there from point 3 to 4. So work done during expansion is P3 V3. What will be the pressure at 3 and volume? P3 V3 minus P4 V4. P4 and V4. I can rewrite this equation like this. RT3 minus RT4. Okay. So this is the work done during expansion. So what will be the total work done? So total work done, everybody know the difference between work done by the compression process and work done by the expansion process. So can I erase it? So net work done. So net work done will be equal to work done during compression process minus work done by your expansion process. Okay. So net work done, that will be equal to N divided by N minus 1 into R in bracket T2 minus T1 minus T3 minus T4. Here I have taken out the common value R outside of from this bracket. Okay. So this will be the total work value of the total work done. Okay. So next, what will be the COP? So how to write the COP? COP is heat absorbed divided by the work done. So COP will be equal to how much heat is absorbed during refrigeration effect divided by the total work done. Divided by the total work done. So look at here. The heat is absorbed during process 4 to 1. Okay, 4 to 1 at constant pressure. Okay. So look at here. The value will be equal to Cp T1 minus T4. This will be the heat absorbed divided by total work done. How much is the total work done? N divided by N minus 1 into R inside bracket this value T2 minus T1 minus T3 minus T4. So this will be the value. Okay, next we also know the gas constant, that will be equal to Cp minus Cv. Okay, Cp minus Cv. So what will happen if I will take out the value of Cv common? So this value will be Cp by Cv minus 1. So I can also write this value Cv into gamma minus 1. Okay, so I will put this value of R over here in this equation. So everybody put this value R in this equation. So this equation will be Cp T1 minus T4 divided by n minus 1 into Cv gamma minus 1, and this value T2 minus T1 minus T3 minus T4 bracket 1. Okay, so again look at here. If I will divide this value by Cp by Cv in upper side and lower side, Cp divided by Cv. So if I will divide over here with Cv, Cp by Cv, so this and here also Cv by Cv, this both will cancel out. Here I can write Cp upon Cv, that will be equal to gamma. Okay, so this is gamma T1 minus T4 divided by n minus 1 into gamma minus 1 T2 minus T1 minus T3 minus T4 bracket close. Okay, so everybody note on this question. Priya. Now better look at here. What if I will divide both side, upper side and lower side, by gamma? If I will divide this equation by gamma and this also by gamma, then this equation will be equal to T1 minus T4 divided by, look at here, n divided by n minus 1 into gamma minus 1 divided by gamma in bracket T2 minus T1 minus T3 minus T4. So this will be the final value of this equation. Now look at here. For isentropic compression or expansion, the value of n will be equal to gamma for isentropic compression. So this equation will be, you can also write this equation like this. Both are cancelled out, these two values, and remaining value is T2 minus T1 minus T3 minus T4. Okay. Now further you can also rewrite this equation like this. T1 minus T4 divided by this equation you can also write like this. T2 minus T3 minus T1 minus T4. You can also write this equation like this. T2 minus T3 minus T1 minus T4. So this is all about the COP of your this Bell-Coleman cycle for your isentropic compression and isentropic expansion process. Okay, so everybody note on these two equations. First was the COP when your heat was gaining, when heat is extracted from your system and to move it to the surrounding. Okay, now second is the COP during your isentropic compression and during your isentropic expansion. So note down, this is the COP, theoretical COP of during your isentropic expansion or compression. Hurry up.
No, sir.
Note on. Have everybody note on it? चंदन नोट कर लिया? Urban?
Yes, sir.
Did you note it?
Yes, sir. Yes, sir.
Okay. Now I am going to erase it. But I am going to share this numerical. Everybody note on this, the value of this numerical. Beta, first everybody note on it. In a refrigeration plant working on Bell-Coleman cycle, air is compressed from 5 bar to 1 bar. Okay. Its initial temperature is 10 degrees centigrade. After compression, the air is cooled up to 20 degrees centigrade in cooler before expanding back to a pressure of 1 bar. Determine the theoretical COP of the plant and net refrigeration effect. The value of CP and CV. So first is the value of your CP. What will be the value of CP? 1.005 and the value of CV is 0.718. Okay, so everybody note on this in your copy. Then I will explain on the blackboard. Hurry up. Everybody note on this value. Now, to solve this, before solving this numerical, first of all, you have to draw the PV and PS diagram. First of all, you have to draw the value of PV This is the value of PV and second here temperature and entropy diagram. One, two, three, four. This is the value 1, 2, 3, 4. Isentropic compression and isentropic expansion. So everybody draw this value. So look at here. How much pressure is given in this statement? So here the pressure is given Bell-Coleman cycle 5 to 1 bar. So 5 means higher pressure. P2 is equal to P3, that will be equal to 5 bar, and lower pressure will be P1, that will be equal to P4, 1 bar. So here the pressure will be 1 bar, and here the pressure will be 5 bar. Now, what will be the value of temperature is given 1 bar. Its initial temperature is 10 degrees centigrade. Initial temperature from where it is starting. So here the value of temperature T1, that will be equal to 10 degrees centigrade. T1, the value, sorry. Now look at here on the blackboard. So this value are given. First of all, you have to draw these two values, PV and TS diagram. So this is your TS diagram, PV and TS diagram. So here the value of pressure is given. T3 will be equal to T2. Jump. P2 will be equal to P3. Both pressure have maximum value 5 bar. Or lower value of pressure P1 will be equal to P4, that will be equal to 1 bar. Okay. Now next, from temperature and entropy diagram, look at here. Look at here, the initial temperature is given is 10 degrees centigrade. So initial temperature I will take from value 1. So the temperature T1 will be equal to 10 degrees centigrade. And now you have to convert this value into Kelvin. 273 plus 10, that will be equal to 283 Kelvin. Okay. Now what is given next? After compression, the air is cooled up to in a cooler before expanding back to a pressure. Before, okay. Before mean before expanding. So the value of T3 is given. Oh, what is the value of T3 is given? The value of T3 is given is that will be equal to 20. Okay. So the value here given is 20. So the value of T3 that will be equal to 20 plus 273, that will come out to be 293 Kelvin. Okay. So now what we have to find out? We have to find out the value of COP and net refrigeration effect. So in this case, both the value of CP and CV is given. So the value, both the value of CP and CV will be given. So value of gamma will be comes out to be, if these two values is not given, the value of gamma will be equal to 1.4. Okay, but these two values is given. So you have to calculate these two values. Okay, so by putting these two values, 1.005 divided by 0.718, this will also comes out to be 1.4. Okay, so the value of gamma also comes out to be 1.4 here in this case. Now everybody know for isentropic compression. So look at here, T2 by T1, that will be equal to T2 by P1 gamma minus 1 divided by gamma, and for T3 by T4, that will be equal to P3 by P4 gamma minus 1 divided by gamma. So now look at here, in this case, we have to find out the value of COP. The theoretical COP comes out to be, everybody know, the value of COP, that will be equal to T4 divided by T3 minus T4. So in this case, you have to find out the value of T4 and T3. From where you can get the value of T3 and T4? From this equation, you can find out the value of T3 and T4. So everybody solve yourself and find out the value of T3 and T4 from this equation, and put this value T3 and T4, and you will get the value of COP from here. Okay. Now next, what we have to find out? We have to find out the value of refrigeration effect. How we can find out the value of refrigeration effect? That refrigeration effect value will be equal to Cp refrigeration effect. That will be equal to Cp. Where is refrigeration effect is occurring? In this from T1 minus T4. T1 minus T4. When you will put this value in this equation, you will get the value of refrigeration effect from here. So everybody calculate the value from this equation. Hurry up. Everybody must calculate this value. So better find out the value of T3 and T4 first. Everybody. Chandan, find out the value. So what is the value coming? Arpans, you tell me. What is the value of T4 and T3?
So the value of T3 is given 293 and the value of T4 is 184.97.
Very good. So you can also write it 185. Okay.
Yes, sir.
See near board 185. So put this value and you will find the value of COP. Okay. Put both this value in the question and you will get the value of COP. Now calculate the refrigeration effect. I have already given the formula on the blackboard. So simple, you have to, what will be the value of T1? At T4 value you have already found out. Okay. So putting that both the value T1 and T4, you will get the refrigeration effect from this equation, which is written on the blackboard. Hurry up.
So the value of COP is 1.712 and refrigeration effect is 98490.
Very good. So value of COP comes out to be 1.713 and the value of refrigeration effect comes out to be 98.5 kilojoule per kilogram. Okay. So beta everybody must solve it. So beta next numerical is your write on a refrigerator working on Bell-Coleman cycle operate between pressure of 1.05 bar and 8.5 bar and 8.5 bar. Air is drawn from the cold chamber at 10 degrees centigrade, compressed and then cooled to 30 degrees centigrade before entering into the expansion cylinder. The expansion and compression, note on it, the expansion and compression processes following the law PV 1.3 is equal to constant. So in this case, value of n is given. N is equal to 1.3. PV raised to power 1.3 is equal to constant. Determine the theoretical COP of the system. Determine the theoretical COP of the system. So to find out the
Excuse me,
value,
sir.
yes.
सर क्वेश्चन सर इतनी जल्दी बोल दिया सर, कुछ लिखना ही नहीं पाया, रेफ्रिजरेटर ही लिख पाए सर.
Okay, I am going to share the screen. Second, look at here a refrigerator working on Bell-Coleman cycle operate between pressure. It is pressure of 1.05 bar to and 8.5 bar. Air is drawn from the cold chamber at 10 degrees centigrade. Compressed. It is compressed and then cooled to 30 degrees centigrade before entering into the expansion cylinder. The expansion and compression process following the law PV 1.3 is equal to constant. Determine the theoretical COP of the system. Okay. Note on it. So beta, I'm going to give you the hint how to solve this numerical. First of all, again, the value of P3 is equal to P2 is given. How much? 1 bar and what will be the value is given? .05 bar. नेट बंद हो गया मैसेज पाते ग्रुप